Hello, and welcome back to our general statistics lectures. Today we're going to discuss Chapter 7, Plotting Points and Lines. This chapter is primarily a review of math concepts and skills that we'll use in the next few chapters, and then again a few chapters down the road. And in today's lecture, we're just going to review some of the really most important points in this chapter and do some exercises. And we'll be able to keep reviewing this material when we get into correlation and regression, because we will be applying the skills from Chapter 7 directly when we are doing correlation, regression, and then down the road, we're going to do more with correlation, predicting points and things. So it is important to know this material, and I'm going to go through it though at a fairly rapid pace. If you have questions as I'm going along, stop me. For those of you at home watching this on the video, I know we're all at home. If you're watching this on the video and thinking, how can I stop her if I have questions? You can always text me with your questions. So if you're watching any of our lecture videos and you think, boy, I wish I could ask a question about that topic right now, please feel free to send me a text message quick, and I usually get back to people very quickly, and I'll be happy to answer your questions as you encounter them. The first topic we discussed was reading and plotting points. Points have a standard format for their plots, and this is the first couple of sections in your chapter. And points are always written x, y, so x is the point on the x-axis or the horizontal axis, and y is the point on the vertical axis. And if we see here, figure 3 shows 5 points, and you can see them right there. And if we look at the x-coordinate and the y-coordinate of these points, we can see that point A is 1, comma, 2. B would be 4, comma, 4. C is 5, comma, 3, and so forth. And so you just, note directly the point that they're at on each of these variables. It's important to remember that x and y each represent a variable. They're each interval level variables, because we can only do scatter plots and correlations, plot lines, when we're looking at the relationship of two interval level variables. There's clear mathematical reasoning for that, which we'll discuss a little bit when we get into correlation. As you move from point A to point B, your x-coordinate goes up from point A to B here. Your x-coordinate goes up by, 1, 2, 3. Your y-coordinate goes up by 2. Okay, and so this is you'll see the theme here. One point in figure 3 has a y-coordinate bigger than the y-coordinate of point E. We can see point E here. Where's our y-coordinate? Remember, it's the vertical axis is our y-axis. Has a y-coordinate 1 bigger. Well, that'd have to be point D, right? The next really important topic is finding the slope and the intercept. This is very important. Now, we're going to use this when we get into regression a lot, and we'll be using plotting points because later on too, because we're going to get into predicting points, and based on the x-axis, we'll be able to predict, which is the independent variable always. So we'll be able to predict the dependent variable or outcome variable on the y-axis. So that's what a lot of this is leading up to, as well as the strength and direction of relationships. So we look at the slope. we can see that the slope is equal to, oh gosh. The slope is always the rise over the run. The rise is how high it goes, the run is how far. We can see that the slope in this figure is 1.5, and the intercept is the value of y when x is 0. The intercept may or may not be meaningful in any particular scatter plot or correlation, but it's always something that you need to identify when doing these kinds of problems. And take note that the slope is denoted by the letter M. Sometimes the letter B is used, so if I accidentally say B, that's what I mean, but I'm trying to adjust my terminology to your book, which uses M, another standard term. And this happens sometimes in statistics where we do have a couple of different ways to represent standard things. So our slope is M, and the intercept is always denoted by A. And that's quite standard, that the intercept is A. And we can see, just to round out this figure here, we can see the intercept is 1. That's where our line intersects the y-axis. Let's look real quickly at this figure, figure 15, and figure out what's the slope here. Well, as we just discussed, it's the rise over the run. And so our rise is measured by the change in y. Excuse me. So we've got here the change in y is 5. Oops. Slope, so rise over run is equal to our rise 5 over our run, which is 2. And the intercept, where x is 0, when x is 0, y is -5. Here we have some example lines, and for each line, let's quickly figure out the slope and the intercept. So we can see that the slope, that our lines don't all go in the same direction. So for figure 17 and 18, we've got a positive slope, whereas in figure 16, we've got a negative slope. And a negative slope is denoted by a negative sign, but it's still found in the same way. So we still are using M is equal to the rise over the run. And so our slope will here be, our rise will be 1, and our run is 4, but it's negative. And we'll talk about the specific meaning of a negative association in correlation. Here we have figure 17, excuse me, and we can see this is a positive slope, and we've got a rise of 10. Over 4. Now I'm just reading these off in the quickest way possible. This rise in standard mathematical sense, you would reduce a fraction so that this would actually, these numbers both divide by 2, right? So we instead would have 5 over 2 in a reduced form. On figure 17, well, for each, when x goes up, it's basically how much does x or does y increase per units of x? So for here I've got, and I've used these somewhat larger intervals than you might, because it's just easier to see on the graphs here. So we can see that when y goes from 0 to 10, y goes up by 10 units, then x is going to go up by, oops, you're right, I did by 2 units. I said that, I realized, but then I wrote down 4. My apologies. So if we reduce this fraction, we can divide it by 2, and it would be 5/1. Where it crosses, Stephen, I'm not sure. Does it go from where it crosses y to where it crosses x? No, it's per unit increase in y over unit increase in x for the corresponding unit increase in y. So here we have y goes up by 10, and our run is 2. It didn't cross at 10. This line does not cross at 10. It crosses at -10. Yeah, but that's I mean, it's true for this one figure, but normally you don't see the negative axis. So you normally can't see where it crosses both axes. That this is a bit of an unusual case in terms of the way they've laid out the visual. It's best to think about it as you could set your units of y to any convenient units. You can see here that they said 10 were convenient, not that they went up in increments of 10 units. So in finding my rise, I went up by 10 units as well. And then I just figured out how many units of x increased for my convenient units of y. And as long as you measure them, as long as you start at the one point and go to a second point and then get the change in x and y between those two, you'll be fine. -10 does matter for the intercept. Yes, the intercept matters, but you can't always see the intercept. As you'll see when we start doing more correlations and getting more lines, plotting more and more lines, you might not necessarily see the intercept on a slope or on a scatter plot, but I guess you would see the y-intercept, but you don't always see the x-intercept, depending on how it's visualized. But the point I'm making is that our statistical programs will generally output the intercept for you. It's when you do correlation or regression, you'll get a whole set of statistics. When you do it in Excel or in SPSS, we get a whole set of statistics in the output, which includes among them the intercept. So the intercept is important. We can see it here, it's -10. Of course, we make note of it, but it's not the same as the slope. So this is our slope. I did neglect to find the intercept for these. My apologies for this first one. Our intercept was course, here, 1. And here it was -10. What's our intercept on figure 18? 0, exactly. We can see that this one's going up 1. The points are 2, 2, 3, 3, 4, 4. So if we continued this graph down, they would be 1, 1, and 0, 0. So the y-intercept would be 0, and the slope would be 1 over 1. For each unit of x, for each unit of y, it goes up by 1, x goes up by 1. Next up, we learned about plotting lines. And so plotting lines is important to understand conceptually. I'll show you how you can plot them in Excel. It's quite easy. And in our lab on Friday, we'll practice doing some of these statistical procedures in SPSS. So you'll get your first introduction to SPSS to get some of these plots and correlation and regression output. So you've got some practice doing that, but it's important to understand what goes into plotting a line. Well, it's important to, if you're doing it by hand, then the process is to take these 3 points. You have a given point, starting point, a construction point where that it's equal to, again, as long as you keep the units the same between your run and your rise, it's you could go over by 6 units and then up by 3. But in this case, they chose to go over by 3 units on the run and find the construction point, and then a corresponding rise for this line is 1.5. So we know the slope of this line right now is 1/2. For each, rise over run. Yes, there are lots of good resources for plotting lines and that allow you to export your graphs. SPSS allows you to export your graphs too. We're going to use Plotly, another excellent resource for getting all kinds of visualizations and for constructing some, they call them dashboards, I think, but they're the beginning stages of infographics. So we'll explore some of these resources. I'll take a look at Desmos as well. So I always like to look at new resources. Thank you, Stephanie. So yeah, there's no shortage of ways to do correlation online. And so, oops. Oh, this is not right. I'm not sure what happened to the axis that I normally use. But so I'll just draw them out. I know, I'm sorry, it's hard to draw a really straight line on here, but So now we have our x-axis here and our y-axis here. And if we're going to draw lines through the point 2, 1 with these slopes, let's use these as some, we'll call this 2, 4, which makes this point 1, 2. You can see how I'm just choosing convenient intervals. And we want to start at point, draw a line through point 2, 1. So we can find our 2x and y is 1. So we want to draw a line through this point with the following slopes. So if our slope is just 1, then as x goes up by 1, then y goes up by 1. So our line would go through the x-axis at 1. And you can see that the rise here is 1 and the run is 1. For our second slope, a -1 slope, we would go in the opposite direction. So here we have 3, same principle. Oops. As x changes by 1, y changes by 1. And if we had a line through the point 2, 1 with a slope of 0, then that's going to be a flat line. That means there's no change in x for a change in y. If we move over 2 and up 1, start at this point, move over 2 and up 1, will we be on the line or below the line? Well, obviously we'd be, if we're looking at our first line, we're, I didn't quite make that long enough. And in case you're wondering, why doesn't she just do these all in Excel? Well, I do have a good reason, because if I do everything in Excel then and have it all ready ahead of time, some students complain that I don't show the process for doing it. If I show all the processes, then other students complain it's not all there ahead of time. So I mix it up. So we have some things that are there ahead of time, some things where we walk through it. I try to strategically, I plan that out strategically. So we're more likely to go through it in the beginning, the first early exercises, and then I have the data on the later ones. But in case you're wondering, it's not random. It's really strategically planned. So if we move over 2 and up 1, here we've moved over 2 points and up 1, so we're below the line. If you move over 2 and up 1 on this next one, then you're above the line quite a bit on our orange line here. And on our flat line, we end up above the line. You move over 2 and up 1, we're above. And if we moved over 4 but up 2, we would see relatively similar trends, and the same for 4. We don't need to do those ones. Let's just we'll go ahead and draw these extra lines just in case there's viewers at home. Why does it do that? If we draw the line with the intercept 2 and the slope -1, what does it mean if our slope is -1? Well, that means that our general direction is going to be in the negative direction. As one variable increases, the other decreases. And the line goes through the point 0, 2. So if I know the line goes through the point 0, 2, I go over here to 0 and up to 2. And we know our point goes through this line. So if we start with this line and we have a slope, if we know our line goes through 0, 2, and our slope is a -1, that means for each unit of x, we go down 1 unit of y. So we know our point's going to go through the x-axis at 2 also. Imagine that line straight. And you can see there's the negative correlation, or I guess I'm previewing our next lecture. This would be also a negative correlation in addition to a negative slope. And the line with the intercept 2 and a slope of 1 goes in the opposite direction. So now we're going in the positive direction, but as we go through up by 1 unit of y, we go over by 1 unit of x. And so you can see how if we have the slope and the intercept, then that's sufficient information to find a line. We've just proved that. It's important to know this equation, y equals mx plus b. And we're going to use this again in the future quite a bit. So let's practice thinking about this equation and how it might map onto some actual lines. Now, if we are going to match each of these equations with each of the lines, let's start out by first just looking at our diagram. You should always start, if you've got a visual, look at the visual first. Oftentimes, visual ways of organizing information are faster to interpret, and people are generally more accurate at interpreting them. And I can already see a couple of important things. I know that lines B and C are both negative. So that means this one positive line, A, must match the one equation here that has a positive slope. So here, this is first equation shows us a positive slope, whereas these latter two show us a negative slope. So this one must be A. Now we have to look at distinguishing between these other two. So I can see that they have a similar slope, but one is got a more dramatic incline. One's a little flatter. B is a little flatter than C. But the most accurate way to distinguish between these two lines is to look at your intercept. So if I know that the intercept for this equation is 4, then it must be line B. And our final line, C, fits all the right criteria. It's best not to assume you've done everything right. Always check your answers. And we can see here, this has a slope of 2 and an intercept of 2 and a slope of 1/2, -1/2. So as y goes down by 1, x goes down by 2. Here we have y going down by 1 and x going down by 2, or up by 2, but change in x and change in y. Okay, does that make sense? I think this is the last problem we're going to do from chapter 7. Oh, but I do have 2 problems on here. So first, we are asked to plot the points 1, 2, 3, or 1, 1, 2, 2, 3, 3, and 4, 4 on the same graph, and they lie on a line. Here we can see the line. I did this in Excel, and I'll show you quickly how I did it. So here we have X and Y. And if I want to get a scatter plot of these two variables, it's very easy. I'm going to highlight the variables themselves and then go up to charts and you can see that there's several scatter plots to choose from. I can choose from one that just gives the points, or one that includes a line, one that just includes the line, and these other ones are not going to look any different for our data. So I'm going to choose the scatter plot with a smooth line, and there you have it. So it's very easy to do these in Excel. And although there are a lot of tools out there for doing it, I still like to use Excel for simple visualizations like this because it's practically ubiquitous. It's probably on your computers at work. It's in all the computer labs. It's a resource you can reliably get to know and use to do a lot of the different procedures that we'll do in statistics. So without us having to use too many other additional resources, because there's almost too many out there. So I see your question, Stephen. It's A and B for intercept. No, B is the slope, but with your book is using M. I mentioned that I am more accustomed to the V for slope, but either one is acceptable. The intercept is always A, and these are always lowercase. They said B equals intercept. Somehow I didn't catch that. It's the intercept. I mean, this is what I'm saying. That sometimes different terminology is used in these. I'm sure it's slide 7. Oh, yes. So it did say mx plus b. You know what? It doesn't matter what letter. I mean, you could either, for this, in this situation, lines are either written like this, or like this. We could change the terms around, so this would be equivalent to, it doesn't matter. Whatever the term that's by itself is always the intercept. And in a line equation, the slope will be paired with the x variable. And so you'll see, just to give you a little preview of where this is going in regression, you'll see that, well, first we'll do just simple regression where we just have one x variable here, but it's possible to look at more than one variable in the same plot. So you will eventually in this class, for a little preview, see equations where we've got a slope plus multiple x values. So we'd have an m for x1 plus the m for our second x variable. And you could have several different predictor variables. X's are always predictors, remember. Always. And so as you'll see when we get into the latter stages of our class, we will look at situations where there's more than one predictor. And you see this all the time when you're reading research literature. You'll even see in lots of results sections where, since regression is very, very popular right now, you'll see that good researchers have written out their whole equations for their analyses using this very format that we've outlined. And again, it doesn't matter if they chose to use B for the slope or M for the slope. It's the basic format where the intercept plus slope times X. And I wanted to introduce these both to you because sometimes people like to use other resources online, and I applaud that. It's good to do. But you'll certainly see this equation for a line written either of these two ways. One final point on this note. Another application we're going to do is looking at predicting Y. This little hat on top of the Y means it's a prediction. And we'll predict Y based on knowing values of X. So we'll have our slope, and we'll put in a value for X. So when X is 1, Y is whatever it is. And so these are the two applications that you'll see for this particular concept. And these are, again, very popular. And I'm mentioning them because it's helpful to preview these things ahead of time because students often find the regression kind of tricky. So I'm trying to lead you gradually down the regression rabbit hole. This other formula over here where I've got multiple variables together, this would be called a model. That makes it look like that's the slope, sorry. So this is modeling because this is the model for Y. Modeling this Y is our outcome variable, and we're modeling how the outcome variable works with respect to these other variables or just one variable. Okay. And these equations are the same except that people have just chosen different notation. Thank you, Stephen. That was a great question and really helpful. So let's go back to our final problem here. We can see that my plot from Excel is in here. And moving a graphic from Excel is really easy. It's here, and all I do is just click on it, and you copy, control copy, or copy, through the right click, and you can paste it anywhere you want in any Word document at least, or Word, PowerPoint, OneNote, any Microsoft, probably other areas as well. Another fun thing you can do is save it as a picture, but we'll go over that if we need to later. Not really essential for today's lecture. So this is our graph here, our scatter plot, and you can see the line. What's the equation of this line? Well, if our equation I'm going to start with Y and use our standard formula. M is our slope. Our slope is, what's our slope? Peanut gallery, 1. Yeah, thank you. Our slope is 1, or 1 over 1. So for each increase, as X goes up by 1, Y goes up by 1. X, it's a placeholder for when in the future we would substitute in values of X here to predict values of Y. Plus B. Now what's our intercept? We've already seen a similar line just a moment ago. It's 0. Yeah, thank you. And so that's the equation for this line, and see how simple it is to find these equations. So we're going to learn to find these simpler line equations so that it makes sense when we are using more complex equations for models. And I wanted to also take a look at these 0.5. But we're looking at the same scatter plot here. So for each of these points, let's see if it's on the line or below. Well, 0, 0 is our intercept, so it's on the line for sure. 1.5, 2.5. Well, that doesn't make sense. I don't even need to look it up because I know that this goes up by even intervals. If our points are 1 and 1, 1, 2, 2, 3, 3, then this line has to go along so that always the points are x and y are the same. So we've got 1, 1, 2, 2. So when x is 1.5, y is also 1.5. And where does this lie? It's got to be above the line because our y-axis is the one that's too high. In this case, if we went to 2.5, we can see 1.5 is going to be below the line. It's certainly, just to reiterate, anything that's on the line is going to fit this same format. Okay. Thanks, everybody. Now let's take a little break, and when we come back, we'll discuss correlation.